acceleration of container. At least I'm helping with some diagram here. With uniform leftward acceleration, is it okay? The free surface should align itself. Theta is that particular thing. So here this will be alpha. So what is alpha? Angle made by the free surface with the horizontal. What approach should be there? Okay, you do one thing. If there is no acceleration, tell me how the liquid will exert force on this particular glass sphere. I'm just building up the idea for next week class. If there were no acceleration, okay, let's assume that there's no acceleration. No? So how the liquid will exert force? The net force exerted by the liquid on the sphere will be vertically up. No, because of acceleration, G effective will come. Because of acceleration, G effective will be there. So in what direction the resultant force by the liquid on the sphere will be? Should be in this direction. Should be in this direction. The resultant force. Some angle it will make. Let's not bother that one. We can calculate that angle very easily. So it will make some angle. The resultant force will make some angle here. So this alpha is there. From that we'll come to know. If the container were at rest, the net force exerted by liquid on the solid will be vertically up because of the acceleration. The resultant force by the liquid on the solid will be in this direction. Okay, let's get into the showing the various forces that are acting. Weight mg. I'm just bringing pseudo force also because we have not done any problem with the pseudo forces. That's why just introducing pseudo force. Of course, we did pressure in accelerating fluids. In terms of force, I'm trying to bring one condition. So there's a normal contact. Here, normal contact. What about the force due to the it should be like this. So there's the force by the liquid. Now what can be this angle? Shall we put same alpha only? So how come? So there's a resultant force exerted by the liquid on the sphere. And it should be directed perpendicular to free surface. What is that FL? How to calculate FL? If the sphere were at rest, what would have been that force? Density of liquid, volume V into G, no? If container at rest. Since container moving, effective G, what is effective G? I think I gave one question in assignment which was related to like this thinking only. Even in static fluids, I can ask you some sort of forces related to this. If container were at rest, it would have been only G. Because of acceleration of container, effective G will come into picture. Okay, I think rest all everything equating forces. What is tan alpha? Tan alpha should be A by G. Tan alpha should be equal to A by G. So let's equate all the forces along X, along Y axis here. So this will be FL sine alpha. For first along Y axis, I'll make it FL cos alpha plus N1 minus mg minus mg minus N2. They should be equal to N2 sine theta, N2 cos theta. Here, this particular point. This will be theta here, no? I'll write one more. I think all the angles are there, so it should be equal to 0. This is along Y axis. Under action of all this, it is in equilibrium. It will not move. Himself is telling that one. So along x-axis will equate forces. FL sine alpha minus MA plus N2 sine theta minus MA equal to 0. I think solving all this will get it. So what is the question asked? Find the force of normal action between the bottom of vessel and the glass sphere. So what is being asked? I think N1. Solving for N1 is needed. Rho W, water, rho W. What is M? M will be rho into V. Good observation, because I know students what happen, they'll try to do integration. You will get answer very lengthy, 2.5 pages it will come. But smart way of thinking. So this, I wanted you to think this one. Later on, the next week, we'll call this as what? Buoyant force. Finish over. This later on, the next chapter will give name for this force. Force exerted by the liquid on the solid. That we'll call buoyant force. Or thrust. So